This is an additional video for the students doing either the higher combined science GCSE course or the students doing the triple science course. The only extra information that you need to know is how to calculate relative atomic mass. We're going to start by looking at isotopes. So just a reminder, you should have also watched the previous video where we talked about isotopes. So we're now looking at the 3 isotopes of lithium. And this is the entry for lithium on the periodic table. So why have they chose this particular isotope to be the entry on the periodic table? There's a key word here, which is abundance. So lithium-7 is found in the highest abundance, so it is the entry on the periodic table. The other 2 isotopes, they do exist in nature, but they're very, very rare. So on the periodic table, if there is one particular isotope of an element which is found in the highest abundance, it will be the entry on the periodic table. However, some entries on the periodic table are not so simple. So chlorine has a mass of 35.5. Now, how can this be? Because chlorine can't have 35.5 protons and neutrons. The reason why is because there's 2 isotopes of chlorine found in nature. There is chlorine-35 and chlorine with a mass of 37. Which one of these do you think is found in the highest abundance? Pause the video now and have a guess. Well, it must be chlorine-35. Because the relative atomic mass on the periodic table is 35.5, this is closer to 35 than it is to 37. So how this is calculated is because 75% of all chlorine found in nature is chlorine-35 and 25% is chlorine-37. Then if you worked out the relative atomic mass, this would give an average of 35.5. And you have to be able to do these. So I have a question here. If you would like to pause the video and figure out, can you already answer these now? That would be really useful. Okay, so copper has 2 isotopes, copper-63 and copper-65. We can ignore the proton number because what we're calculating here is the relative atomic mass. So we're only interested in the mass numbers. So which of the coppers is in the highest abundance? So copper-63 is 69%. So this is the most abundant. So when we calculate the relative atomic mass, the average of these 2 different isotopes that are found in nature, if we're calculating the average, the closest, it's going to be closer to 63 than it will be to 65. But the number has to be in between them 2 numbers. So if we calculate it and it's 40 something, we're wrong. If it's 80 something, we're wrong. The number needs to be between 63 and 65, but it must be closer to 63. The maths in this I actually find quite easy. All we really need to do is turn the percentages into proportions. So divide the percentage by 100 to turn it into a decimal. So 69% becomes 0.69 and 31% becomes 0.31. What we have to do next is we're just going to times the mass number by that proportion. So the one that has the highest proportion is going to have the highest number. We then need to add these 2 numbers together to get the relative atomic mass. And if we do that, we get the number 63.62. Is this between 63 and 65? Yes, it is. Is it closer to 63? Brilliant. But we would actually drop a mark if we did this on our exam because the question has asked us to give our answer to 1 decimal place. So the final answer is 63.6. It's really important now that you try and answer a few questions. So in the higher and triple question worksheet, there is another example of these questions. You can also find other examples on websites such as Maths Made Easy. Remember, the more questions that you do, the more progress you're going to make. But well done for watching. Thank you so much. Remember to send an email to your science teacher if you don't understand anything that's been said in this video. Stay safe. Thank you very much.